This is the paper called Gabble, Managing Integration Knowledge in IoT Systems with Logical Reasoning. Interoperability in the Internet of Things is still a problem, because in today's IoT systems, a lot of different syntactic interface descriptions for similar concepts exist. Current solutions, such as E-class standard or semantic web service description languages, cannot be effectively applied in IoT systems because they require a complete description of the semantic domain when IoT interfaces are integrated. The Gabble tool now explicitly allows for an incomplete semantic domain model by looking at integration cases instead of domain models. Gabble is embedded into the sophisticated engineering method called knowledge-driven architecture composition and assists the system integrator at design time by proposing interface mappings based on previous integration cases and generating a software adapter in an automated way. Let's look at an example. Suppose you have an interface from device A and B, and you manually define those mappings. You do this for the devices B and C as well. Then we can actually automatically infer integration cases 3 to 6. Let's look at these examples at scale. So we can represent here an interface description as nodes and interface mapping as edges, and then we basically compute a fully connected graph from a weakly connected graph that may contain also incomplete mappings. Let's see how these mappings are managed in the Gabble tool.
All right, so let's jump directly into the tool demo. So first we have to add our interfaces. To do this, we select an open API definition for them. And we do the same for interface B here. And now we can start to create the mappings. So we first select our source interface and the corresponding operation. And then we select our target interface here. And as we can see, the two data models get rendered below. And now we can start to create the mappings between the different attributes. And now let's say for the brightness, we want to do some more sophisticated mapping logic, and we want to do a replacement of a string to an integer. So we add this logic in here, and then we save it. Then we continue to the response, and once we add our last mapping here, we can save this mapping. Now let's do the mapping from B to C. So first we add interface C again, and then we can start to do the mapping once more. So as we select C, we can see that there are basically two operations here that correspond to the same operation in B. So we have to do a one-to-n mapping here. So we select both those operations, and then just like before, we add the mappings. Let's say for brightness, once again, we do some substitution, and we want to convert a value between 0 and 100 to a value between 0 and 1. So we add a division right here. And finally, we add this color attribute, and then we can continue to the response. Now here we can see that there is no corresponding attribute for the success attribute. So we add it and we simply give it a constant value. Then we add the rest of the attributes, and now let's try to test this mapping. And so we enter some test data and we execute it, and as we can see, there's an issue. So let's see why this is. And indeed, the brightness has a value of 5, where we would expect a value between 0 and 1. So let's check where the error is. And as we can see, we divided by 10 instead of 100. So we fix this mistake, save it, try to execute the test one more time, and now it works. So now we can continue to create a mapping between interface A and C. So once more, we select A as a source. Now for C, as we open the operations, we can see that the operations are marked by an asterisk, which basically means that a mapping can automatically be deduced between A and C. So we once more select both those operations, and now we already see that there are some suggestions rendered to the mapping area, and those are created by simply inferring the logic based on the integration cases that we stored before. So for example, let's look at this brightness mapping. And in here we see that first we have our substitution from string to integer, and then we have the division by 100 that we defined in the second mapping. And if we look at the response, basically the same picture. We also have everything already here as a suggestion, so we don't need to do anything here. Now we can test this again, and as we can see, we changed the brightness from medium 2.66, which is basically this chaining of mapping operations. And finally, we can save this, and we can also create an adapter. And as a result, we will get a downloadable code repository that we can then add to our source code.
What you should remember from this tool. Gabble allows for case-based formalization of integration knowledge to enable automated component coupling. And Gabble might be interesting to you if one of the following topics are relevant to you. You can hardly standardize your use cases or your domain. IoT integration knowledge transfer and retention is critical. You need to integrate a multitude of heterogeneous devices across different code bases, and you want to ultimately implement plug and play for your IoT devices. And with that, I would like to end the presentation. Thank you for your attention.